We'll see if we can get through this one. All right, homework 18 is now going to talk about a different kind of distribution, which is the F distribution.
Oh, I think I need this one. Sorry.
Man, they just didn't give you anything in your binder, did they?
I was actually missing so much. I think like 5 or 6 things so far.
I wonder who copied that. All right. We'll give her a second to kick out of there. Hopefully it's a little faster since we've printed something. All right, so this first part again is just using the Alex calculator and knowing how to do the p-value and the critical value, just like we did with the z-test and the chi-squared and the x-test, all of that. This is just a different distribution. So if you have your Alex open or you have your Alex calculator.
Mine says calculator unavailable for this question.
We'll go to a different question. Let's see if we can get to a different one where we get a calculator that is active. Yeah, maybe its part should be maybe for that one. There we go.
Okay.
So on our Alex calculator, you'll see the last P1 is P of F. Again, the P of F is greater than, so that's going to the right. If we're doing the left, we have to do 1 minus, right? Just like we did before on all the other ones. So we want to do P of F is less than or equal to 1.19. So we're going to do 1 minus that because on the calculator it does greater. We want the less. So 1 minus P of F is greater than 1.19 is how we're going to do that to calculate our number. Oh, this one I think we do have a numerator degree of freedom and denominator degree of freedom. I better remember those. 1.19. And then this one has a degree of freedom for the numerator and a degree of freedom for the denominator. So when you click that, you'll see DFN, which is the numerator one, which is 28. And then you'll have DFD, degree of freedom for the denominator, which is your 40. So on the t-test, we just had that 1 degree of freedom, and same thing with chi-squared. For your f-test, you have both a numerator and denominator degree of freedom. You'll see why later. So that's what we're going to punch into our Alex calculator, and we're going to get our answer to 3 decimal places, it says. .698, yep. 0.698. That is what we're finding when we find the p-value on all of that hypothesis testing. Now we're doing what they're doing for the critical value. Remember when they ask you for the critical value, that's when you're doing the sub thing. Again, it's going to do greater than on Alex. And this one is a greater than. So if it's a greater than, you're just going to use that value. And so I am going to do F sub 0.05 since it's a greater than. And then I have to do my degree of freedom again. So my degree of freedom for my numerator is 46. My degree of freedom for my denominator, 41. So when we do our hypothesis testing, we have those 2 different kind of test values. The p-value, which is a percentage, the critical value, which is the cutoff point as far as your numerical comparison. Rounding to, oh, this one just says we have to round to at least 2 decimal places. 1.66. 1.66 then. Okay.
Mine's not turning out
Oops.
how it's supposed to.
Let me peek and see which one you're using.
This one, right?
Oops, nope, that's the one for the top one where you have the P of. This one is just the one with the subscript.
This one?
So where is that one at? There it is, right there. F sub.
Oh,
Okay? So if it asks for the P value, you use the one with the P. Critical value, you use the subscript one. Now you're getting 1.66?
yeah.
Alrighty. So on number 2 then, we want to do between two numbers. So if we're going to do between two numbers, we're just going to basically subtract the two values. So we're going to do P of F is greater than 0.74 minus the P of F is greater than 1.17. That would give you the part that's in the middle. Oh, and I forgot my degree of freedom again. They're going to ask you for your degree of freedom. I'm going to have on both of them, the degree of freedom for my numerator is 48. The degree of freedom for my denominator going to be 20. You'll have to put that on both of those. You know when you click on it, it gives you the little boxes for that, so you'll remember to do those. So if you punch that into 3 decimal places is where we want to carry this answer.
So it's on the third line, that one?
The one with the P, P of F. Yep. Oops, wait a minute. Are you in the second part of that?
I don't know.
Because you're doing between two numbers, you're going to do this one first,
Oh,
the
okay.
smaller one, and then you're going to subtract the bigger.
Okay, so the one that I was on, that's the right one?
So yep, that's the right one. You're going to put in both parts because you're going to find the part in the middle. So you're going to just take the first one minus the second one. Okay, 0.74 with a degree of freedom on my numerator of 48. On my denominator, it's 20. And then on the outside of that, put your minus sign. And then you're going to do the P of F again. And then you're going to do the second number, 1.17. The degree of freedom again for your numerator was 48. And your denominator was 20. And so, 3 decimal places, my answer is
0.445.
Yep. So when it has you do between two numbers, you're just going to subtract the two, the first one minus the second one. Here's another critical value. My critical value here again is greater. If it's a greater, we're just going to use the number there. And so we're going to do F sub 0.05. Degree of freedom in my numerator is going to be 7. The degree of freedom in my denominator, 48. So that's the one we're going to do the F sub. If it's a greater, just use the number that's there. And again, this just says to 2 decimal places. 2.21 is what we should be getting. There we go. Yep. So, number 3, we want to find our p-value. And We are doing a less than. If we're going to do the less than, what do we have to do with that? 1 minus. So 1 minus P of F is greater than 0.88. It's a greater than, we can just use it, but if it's a less than, 1 minus that. The degree of freedom in my numerator is 39, and the degree of freedom in my denominator, 40.
Okay, which one do I use?
Use the one with the P. 1 minus P of F. Did you do the 1 minus in front? Yep. Okay. 0.88. Yep. The degree of freedom in the numerator was 39. The degree of freedom in the denominator is 40. Whoa, undo. Oops. All right, now type your 40 in. I think you had it highlighted, so try to erase everything. There we go. All right. So, to 3 decimal places we got
0.345.
0.345, right. Okay, now we're doing a critical value. Again, this is a greater than. Since it's a greater than, we can just use our number. Critical value, we use the subscript one. So F sub 0.1. The degree of freedom in my numerator is going to be 12, and the degree of freedom in my denominator, 15. And then we're just going to put that in our calculator.
Could you put it in this calculator too, or no?
No, got to use
Just
the Alex
Alex.
one.
Three places?
2 places on this one.
2.02.
2.02. If you go farther than 2 places, you're okay, because it just says at least 2. So if you did do 3 places, it's still going to count it right.
Okay.
Yeah. All right. Now, we have to think way back when we did confidence interval. The confidence interval means we're finding the lower limit and the upper limit. Our formula for our confidence interval is we're taking the mean from the first thing, or the sample mean from the first thing, I should say, minus the sample mean from the second thing. That goes together, plus or minus z sub something, and they're going to put alpha divided by 2, and we'll talk about that in a minute. And then I didn't leave myself enough room to write. Square root of the standard deviation squared of 1 over n of 1 plus the standard deviation squared of 2 over the n of 2. So, the Human Resource Department of Counseling Firm gives a standard creativity test to a randomly selected group of new hires every year. This year, 65 new hires took the test and scored a mean of 112.8 points with a standard deviation of 16.8. Last year, 100 new hires took the test and scored a mean of 117.2 with a standard deviation of 17.7. Assume that the population standard deviations of the test of all new hires in the current year and the test scores of all new hires in the last year can be estimated by the sample standard deviation, as the samples used were quite large. Construct a 95% confidence interval for our means, the difference of our mean test scores of new hire of the current year and the mean test score of new hires from last year. So the current is going to be my 1s, last year is going to be my 2s. Now, 95% confidence interval. If we think about that, it means that the middle is 95%. That means we're calculating the percent for each of these little sections, and that's going to give us the sub that we're going to use with our z. So, if this is 95% in the middle, we're going to do 1 minus 95%, which is 5%, right? 5% for both of these, but since I have two sections, I then end up dividing by 2, and that's why they give you over 2, because I have those two sections. So I'm going to use 0.025 in for that. This is 0.025, this is 0.025. Those are percentages. Okay? So, in my problem, sample mean 1 is my current year. The mean for the current year was 112.8, right? The mean for last year. My mean for last year my mean was 117.2. So first part of my formula, I'm taking 112.8 minus my 117.2. Plus or minus z sub 0.025. Square root of, now I've got to find my standard deviation squared for each of those, or my standard deviation. So my standard deviation 1 would be my current year standard deviation. That was the 16.8, right? My standard deviation 2 was last year's standard deviation, which is the 17.7. I got to do N1 and N2. N1, how many people did they survey this current year? 65. Last year, 100 new hires took it. So in my formula, for the first part, I'm going to take my 16.8 squared over my 65, plus then my 17.7 squared over my 100. And then we want to try to get that into the Alice calculator the best we can, remembering that it does have the plus or minus option, so we don't have to do two separate problems. We can just get it all punched in. Do use the parentheses around this first part like I wrote it, otherwise you won't get the correct answer. My 112.8 looks a little funny. All right. So, in parentheses, let's clear that out. And we got 112.8 minus 117.2. If it's quicker, you can't type on the keyboard. Whoops, you need parentheses around that. It doesn't look like you have. 112.8 minus 117.2. Close your parenthesis. Plus or minus, which is next to the parenthesis. Right there. Then we have z sub. So we're using the subscript, yep. 0.025. Now we're going to click over to the side, yep, and then do the square root. Under my square root, I want 16.8 squared divided by 65. And then over to, 65 instead of 62. Over the side, yep, plus. And then we're going to have 17.7 squared divided by my 100. And hopefully when we hit equals, we get our two answers. So you'll have to go over to the left. My first answer to two decimal places is?
9.
Was that negative?
Negative 9.76.
Negative 9.76. My upper limit?
Is 0.96.
0.96, okay?
Mine is locked.
This is locked. It was locked down here now. Oh, what does it say there? Wrong. Try your password again. You must type that in wrong.
I didn't.
Caps lock is not on, is it?
Oh,
Oh. I wonder if, try typing in quiz 1. I changed the assessment because I didn't want Leanne to have to do it, and it might have reset the password. Yep, it changed, it's reset the password to quiz 1. All right. So number 5 is going to pretty much be the same thing. If I can get to number 5. Oh, no, it's not, because number 5 is meaner. Number 5, instead of just giving you the means and the standard deviation, they're giving you a table of values. So you either would have to calculate that using the formula or use your graphing calculator. Do you remember how to find the mean and the standard deviation if you have your data on your graphing calculator? First of all, we have to put our lists in, right? So to put our list in, we hit stat first. We put 1 for edit. Clear out anything that you have in there because you don't want anything in there. And you can either do them separately or you can put the first list in list 1, the second list in list 2. I'm just going to put both my lists in at the same time. 1.7.
so put them in separate lists?
Yep, put the first list in list 1, the second list in list 2. You could do them separately and do your calculation, but you might as well put them in while you got the screen open. Let me know when you got your list in. Okay, so then we now are going to do the statistics on that. So we're going to have to do those two separately. But first of all, we'll do list 1. So we're going to hit Stat, go over to Calc, and we're doing the 1 variable statistics, which is number 1. And we want to do the 1 variable statistics on list 1. List 1 is probably already in there unless you're using the older calculator, and then you got to do the shift number 1 to do L1, right? And then we're just going to calculate those 1 variable statistics for list 1. And we are going to write down what the mean, the standard deviation, and the number in our sample. So on list 1, my mean
Oh my gosh.
is going to be the 3.46, right? Got that? My standard deviation one is going to be Did I not type something in right? Oh, I don't have to do the standard. They gave me the standard deviation. That's why I'm looking. They gave that to me. I just have to do the mean and the n. Well, I could have done that probably faster than doing the list then. Doing my mean, I got that. My n, how many numbers did I have? 10. N says 10. And then they're going to give us the standard deviation. So I'm going to use 1.8. On the second one, same thing. If I just hit my stat button again and go to calculate, one variable statistic, but change it to list 2 instead of list 1. So you do shift 2 to get list 2 in there. Again, if we calculate that, my mean, my X bar value is going to be that top number, the 4.17. The N again is 10 it says, and then the standard deviation is going to come from the problem. They're doing 1.5 standard deviation. I didn't realize they weren't doing the standard deviation from the sample, they were doing the given standard deviation. So you could have also just added all those numbers up and then divided by 10, since there were 10 numbers on the list, and you would have come up with that same answer, hopefully. All right, now that we have those numbers, we can get to our formula. So, on our formula, we are going to do the mean from the first minus the mean from the second. So 3.46 minus our 4.17 plus or minus z sub. I have to find my confidence level. My confidence level is 95%. I'm not sure if they all use 95%. They might, but just keep in mind if they don't, we're saying 95% is in the middle and we're finding out each end. So we did 1 minus the 95%, which was 5%. We divided it by 2, so we use 0.025. If they use 95%, you're always going to use 0.025 there, right? 0.025. Then we have, square root of my standard deviation, so 1.8 squared over my n, which is 10, plus my other one was 1.5, so 1.5 squared over my n again, which is my 10. Now you get to practice putting that in there. Can you read my scribbling? Okay.
So wait, where do I put
The z sub, this is going to be the 0.025, that number here. Squared. And both of them happen to be 10 because we had 10 in our sample. So this was the standard deviation squared over n, and then the standard deviation from our problem again, which is the 1.5 there, over the 10 again, because each list had 10. This is going to go right behind this, and this is going to be z sub 0.025. So when we put that in, we're going to start with the parentheses. I'm going to put in the 3.46 minus the 4.17. Close our parentheses. Plus or minus, which is right above the 8. There you go. Then you're going to do the z sub. And that's where we use the 0.025. Okay? Behind that, so just click up a little bit, do the square root. Just under, up right above sort. No, not square, square root. I just said undo. There's the square root, okay? And then under the square root, we're going to have the 1.8 squared over 10, so divided by 10. Click right behind that fraction. Oops, maybe a little bit farther in because you want it to be under the square root. There you go. Plus our 1.5 squared divided by 10. Both those fractions are under that big square. All right, so when you hit equal, if you slide to the left, you're going to see your lower limit, and then if you slide a little bit farther over, you see your upper limit. Okay?
So this is the lower.
So my lower limit to 2 decimal places is,
-2.16.
yep, negative 2.16, and my upper limit was 0.74. Yep.
I did not get that.
Oh, let me see what you got typed in there.
20.
Oh, I'm gonna undo so I can see what you have. Just hit undo here. Okay. Ah, see, you didn't get this up back here. You got it down there in the subscript.
Okay.
So let's just back this up.
Undo.
You can undo for a bunch. Okay, whoops, put the 5 back in. Now you have to click up higher. There you go. Now do your square root. Okay, so you have 1.8 squared. Woo,
Oh, whoops. Undo.
squared. That one, there you go. Over, divided by 10. And then right behind that fraction, yep, 1.5 squared.
Plus?
Yep, plus 1.5 squared. Sorry about that. Squared, yep, divided by 10. Now if you hit equals, do you get those two numbers? Now we look better, right?
Yeah.
Okay, so just make sure you get out of that subscript when you do your square root. All right, number 6. Random and independent samples of 100 recent primetime airings from each of the 2 major networks have been considered. The first network aired a mean of 110.6 commercials during prime time with a standard deviation of 4.3. Second one aired a mean of 109.4 commercials with a standard deviation of 4.3. As the sample size are quite large, we want to find the the population standard deviation can be estimated. The sample standard deviation. Construct a 95% confidence interval for my mean difference. And so again, we're going to find our upper and our lower limits. This time they were nice because instead of giving us the big long list, they just told us the numbers to use. So, in our formula, we are going to take the mean from sample 1 minus the mean from sample 2. What is the mean from sample 1? $110.6. What's the mean from sample 2? 109.4. So we're going to take our 110.6 minus our 109.4, right? Plus or minus z sub. Again, they gave me 95%. I'm thinking they always might give you 95%. So if it's 95%, what are we going to use for z sub what? 0.025. And then we're going to have the square root of, and we need our standard deviation. Our standard deviation from the first sample was 4.3, and for our second sample, it's also 4.3, right? N. N for our first sample is going to be 100, right? And on our second sample, it's still 100, right? They did 100 from each of the 2 major networks. So for both samples, they surveyed 100 people. So we are going to have 4.3 squared over 100 plus 4.3 squared over 100, since they used the same numbers for both of them. Standard deviations were the same. The number of people I surveyed were the same from one network to the other one. Leanne get the answer for you?
It was just too long to type in.
They're just too long to type in? Better than what I did, which was doing it all by hand with the regular calculator. All right. Did we get our lower limit and our upper limit?
0.62.
Whoops.
Oh.
It's not what I got. You got 0.62?
0.65 or 0.625. Oh, you didn't do the squaring on your 4.3s. Did I not write them? Yes, I. Oh, yeah.
Did you both do the same thing? Hit undo for me.
Probably.
Yep. This should be
4.3 squared.
not 4.32. Yep.
Okay.
So make those squares instead. 4.3 squared.
Oh shit. Oh sorry.
Oops. Did you undo if you typed something in wrong or did something?
Is it
There you go.
0.01?
That sounds better.
0.008 I have now.
So 0.008, you're going to round off to 0.1, right? If it's 2 decimal places.
Yeah.
Again, if you go farther than 2, it's going to be okay. It says at least 2. My upper limit's going to be 2.39. Okay. Yes, make sure that looks like a squared and not a 4.32. All right. 7, 8, and 9, we're going to again do confidence intervals. This one has really a whole long ton of formula to get the answer. I had to highlight 2 formulas. First of all here, when I'm doing my confidence interval, this one has a 90% confidence interval. So on my confidence interval, if the middle part is 90%, that means 1 minus 90% would be 10%. 10% divided by 2 means each of those little sections are going to be 5%. So when it was 95%, we use 0.025. If it's a 95% or a 90%, then we use 0.05. So we are first of all going to find what they call SP squared. And the formula for SP squared is n sub 1 minus 1 times S1 squared plus n sub 2 minus 1 times S sub 2 squared over n sub 1 plus n sub 2 minus 2. So, it says, a light bulb manufacturer wants to compare the mean lifetimes of 2 of its light bulbs, Model A and Model B. Independent, random samples of the 2 models were taken. Analytics of 16 bulbs, that means N1 is going to be 16, of Model A showed a mean, which is your X bar that we don't need on the first part, but we'll need later. X bar of 1 is 1,351. Standard deviation, that's going to be your S, of 109. Then I am going to analyze 10 bulbs for my second one. So on my N2, I'm going to do 10 bulbs. My mean for 2 is going to be 1,332, and my standard deviation for 2, 115. So in the first part of my formula here, N1 is 16, so I'm going to do 16 minus 1, or just 15 if it's easier to type it in that way, times my standard deviation squared. So I'm going to have 109 squared plus n2 minus 1. n2 is 10, so 10 minus 1 is going to be 9, times my standard deviation squared, which is 115, so 115 squared. That's all going to be over n1 plus n2 minus 2. So 16 was n1, plus 10 was n2, minus 2 on the bottom. And then we have to calculate that value. Just hit undo.
I highlight all these.
Okay, yep, highlight that whole, whoops. This should be 10 minus 1 instead of 10 minus 9. 9 was my answer when I did the 10 minus 1. But yes, you could just put 10 minus 1 there. And then 115 squared. Otherwise, you could just, instead of doing this, you could just put the 9 and just put the 15 and not have to have the parentheses. Highlight over that whole thing, yep, and then divide it by, and then you're going to have 16 plus 10 minus 2. And it equals. So we get 12,385, right? Mm-hmm. Now, we did all of that, we have to do the confidence interval formula. So like we did on the previous one, which I didn't leave myself a whole lot of space to write, we're going to do the mean 1s minus the mean 2, plus or minus. This one's going to be a t-test. So t sub, we figured out it was going to be 0.05 because our confidence interval was 90. And then we're going to have the square root of behind that, but I have to smush it down there. The square root of my SP squared answer, that was that number we found over here, times 1 over N1 plus 1 over N2. So on this problem, I'm just going to sneak it over here. Mean 1 was 1,351 minus mean 2, 1,332, plus or minus t sub 0.05, and then right behind that, but I can't fit it in, is my square root. My square root under there, I'm going to have the 12,385 times 1 over N1, which was 16, plus 1 over N2, which is 10. So this part should go right behind your T, like we did on our other confidence interval. Oh, yes, the T has to have the degree of freedom. My degree of freedom is going to be whatever you're getting for this bottom number here, which in this case I'd have 26 minus 2, which is going to be 24. So your degree of freedom is going to be that N1 plus N2 minus 2. 16 plus 10 minus 2, 24. I always forget the degree of freedom until I click on it and then it says you have to put the degree of freedom in there. Then I go, oh yeah, I got to do my degree of freedom. So, degree of freedom, it's that bottom part of this fraction, or N1 plus N2 minus 2. So, let's see if we can get all that in there on our calculator.
needed more writing space on this paper, didn't we? I must have wrote smaller with my pencil. All right, so first of all, to clear that out, in parentheses, we've got our 1,351.
1,351. Where did we get that?
That was the mean of our first sample.
Okay.
Then we're going to do minus the mean of our second sample. So minus our 1,332.
Where's that?
That's the mean of the second sample.
Oh.
Okay, close our parenthesis, plus or minus, which is right above the 8.
Where's the 8?
So plus or minus there. Then we're going to do a t sub. So we're going to use the t here. And so we're going to use t sub 0.05 with a degree of freedom of 24. So just straight in that little second box, we're going to put our 24. So the 0.05 we got because we had a 90% confidence interval, which means we have 5% on each end. The degree of freedom of 24 we got by doing the N1 plus the N2 minus 2. So we took 16 plus 10, which is 26. 26 minus 2 is our 24. Behind that, if we click up to the side again, so we're not down in that subscript, now we're going to do the square root part. Not squared, square root. There, yep, first one. Under the square root, we are going to take the answer that we got from here. This is not the answer here, it's just the answer to this. Oops, that was that number. So we're going to use that number there. One, 2, 3, 8, 5. Yep, parenthesis. And then we're going to have 1 over 16, which was 1 over n. So 1 divided by 16. Click right behind the fraction. Oops. Look right next to it. There we go. And then we're going to have 1 over 10, which was the n. Whoops, I forgot the plus sign. Undo a couple. Plus 1 over 10. There we go. Click behind the fraction, close your parenthesis, and now we should be able to hit equal. All right. So, my lower limit to 2 decimal places was, after all that work,
Negative 57175.
and we're just
75,
doing
sorry.
to 2 decimal places. So negative 57.75.
5. Yeah.
Is that what you guys got? I rounded off, so I have a slightly different answer because I was not putting the whole thing in the Alex calculator. All right, and then my upper limit was
95.75.
75. All right, 95.75. So it does give you some leeway in case of rounding. I rounded off my values to 3 decimal places, and so I have a slightly different number, but it will take it as long as it's pretty close to the answer because they know there's rounding issues. All right, so this is kind of a long one because we have to calculate this S-squared or SP squared in order to put into our confidence interval formula. Squeeze number 8 here. It says, the University Data Center has 2 main computers. The center wants to examine whether computer 1 is receiving tasks that require processing times comparable to those of computer 2. A random sample of 12 processing times. So N1 is going to be 12. Showed a mean of 60 seconds. So my mean one going to be 60 with a standard deviation of 19 seconds. So my S1 going to be 19, right? Computer 2. Well, a random sample of 9 processing times from computer 2. So N2, we're only going to do 9 processing times. Shows a mean of 50 seconds. So X bar 2 is 50 with a standard deviation of 18 seconds. And this one again, we're going to use a 90% confidence interval, so we know we're going to do T sub 0.05, right? When we do our degree of freedom, we're going to take N1 plus N2 minus 2. So if I do 12 plus 9 minus 2, my degrees of freedom would be 19. All right, so we have to start off with our first formula when we did our SP squared formula, that very first one. So in our first formula, the first number was N minus 1. You can either put in 12 minus 1 or just do 11 because we know that 12 minus 1 is 11, right? 12 minus 1 times the standard deviation squared, so my standard deviation is 19. Plus N2 minus 1. So again, you can either type in 9 minus 1, or if it's easier, you know 9 minus 1 is 8, right? Times the standard deviation squared, so the 18 squared. Now we now know the bottom number is going to be this value here, so again, you can either put in 12 plus 9 minus 2, or since I figured it out for my degrees of freedom, you can just type in 19 if you prefer. I'll write it out the long way, but you could just put in the 19 since we figured that number out already. And that would make it easier to get it typed in if you did that, some of those calculations ahead of time. So 11 times 19 squared plus 8 times 18 squared divided by 19 would be the quick way to type that in. And this says carry your computations to at least 3 decimal places. This one you're going to have to round off. It doesn't come out nice. Yep. 345.421. You can carry that out more if you like, but you have to have at least 3. Again, you'll get some slightly different answers depending on where you round, but Alex adjusts for that and knows that it's okay. Now that we found that, now we got to do the confidence interval formula. So on our confidence interval formula, we're going to start by subtracting our 2 mean values. So we're going to take 60 minus 50. Then we're going to have the plus or minus, and then we're going to do our t. So t sub 0.05 with a degree of freedom of 19 we already figured out. And then we're going to do our square root. And under our square root, the number that we found here goes first, 345.421. And then in parentheses, 1 over our n value plus 1 over our other n value. So 1 over 12 plus 1 over 9.
Okay, I'm stuck.
Oops. Unstick it.
Okay, what do I do?
You didn't get your parentheses there at the very beginning. Let's just clear that out and start over. Yeah, close that. All right, so parenthesis first. And then the 60 minus the 50. Whoops, 60 minus 50. Oh. Just slow down. It's okay. Parenthesis 60 minus 50. Oops, the 5 didn't go. There we go. Close your parenthesis. Plus or minus T sub 0.05 with a degree of freedom of 19. And click up to the side, put our square root symbol. Square root, not squared. There we go. And then we're going to have the 345.421. Parenthesis. 1 divided by 12. Click behind the fraction. Plus 1 divided by 9. Click behind the fraction. Close that parenthesis. Hit equals. And we get.
Mine won't let me click the equals button.
Oh. What do we got going here? Okay, that all looks like it's there. Don't see anything weird there. 60 minus 50 plus or minus, that looks good. And we have all our parentheses. Oh, it's because the parentheses is on the outside instead of underneath the square root. Back it up. And then click right behind that 1/9 and then close your parentheses. Now, it lets us do it, okay? Yes, you'll have to practice using your calculator for sure. So number 8, my answer is?
Negative 4.17.
Yep.
20, and the second one's 24.17.
Mm-hmm. All right, we're going to leave off there. Next time we'll try to get caught up, but these are really long problems, so like I said, I'm not going to try to kill you too badly, although we missed 6 hours of class with our 2 snow days, and I'd like you to at least do the stuff that they do at other schools. So, we'll get there. I'm going to write myself a note, but if I forget, we left off on number 9. Start here. Try to be here at 2 o'clock next week so that we can get started right away.